A bus covers a distance of 90 kilometers at a uniform speed. Had the speed been 15 kilometers per hour more, it would have taken 5 minutes less for the journey. Find the original speed of the bus. So let's discuss this solution. So let the original speed of the bus be x kilometers. X kilometers per hour. Then time taken to cover a distance of 90 kilometers is 90 over x hours. But new time okay, when the speed is 15 kilometers per hour more, we have x plus 15 kilometers per hour at the bus speed. So which means that time taken in this case would be the distance, which is 90, over now this speed, which is x plus 15 kilometers per hour. So if a bus covers a distance of 90 kilometers at a uniform speed, and if the speed is increased by 15 kilometers per hour, then it will take 30 minutes less for the journey. So it means that now the differences between these two times is what should give us 30 minutes or half an hour. And note that 90 over x is more than 90 over x plus 15. So which means that 90 over x minus 90 over x plus 15 is what's giving us 30 minutes, which is the same as a half an hour. So LCM is x into x plus 15. So we'll have 90 into x plus 15 minus 90x equals to a half. So we'll have 90x plus 90 by 15, 1350 minus 90x over x squared plus 15x equals to a half. So this and this cancels out. So we have 1350 times 2 equals to x squared plus 15x. So when you multiply 1350 by 2, you get 2700. So this is simply a quadratic. So which would be the same as x squared plus 15x minus 2700 equals to 0. And number product here is minus 2700. Sum is 15. Numbers which will give us this. We have 60 and minus 45. So that we'll have x squared minus 45x plus 60x minus 2700 equals to 0. So we'll have x into x minus 45 plus 60 into x minus 45 equals to 0. So x minus 45 times x plus 60 equals to 0. And that gives us x equals to 45 or x equals to minus 60. But this one we don't expect to get a negative answer, so we ignore. Hence, the original speed of the bus should be 45 kilometers per hour. So next question, if f of x equals to x squared plus kx plus 1 for all x, and f is an even function, find k. And then the next is to find k if f is an odd function. So we have f of x given by x squared plus kx plus 1. So f of minus x will be given by minus x squared plus k into minus x plus 1. So it will be x squared minus kx plus 1. For f to be even, then f of minus x is the same as f of x. So this will mean that x squared plus kx plus 1 equals to x squared minus kx plus 1. So this equation implies that this and this cancels out, 1 and 1 cancels out. So k x equals to minus kx. So 2kx equals to 0. So which means 2k must be 0. So which implies that k equals to 0. So the value of k should be 0. Next, we have been told that f of x given by x cubed minus kx squared plus 2x is odd. then we have to find k. F of minus x will be minus x power 3 minus k into minus x squared. That's by definition. So this will be minus x cubed minus kx minus 2x. Now for f to be odd, it implies f of minus x equals to minus f of x. So which means minus x cubed minus kx minus 2x will be the same as negative of x cubed minus kx squared plus 2x. So we have minus x cubed minus kx minus 2x equals to minus x cubed plus kx squared minus 2x. I'm simply multiplying by negative 1. So which implies we are going to have minus kx equals to kx squared, so minus kx squared. So this is square, this square. There's a square here. So which means 2kx squared equals to 0. So this tells us that 2k equals to 0. K is also 0. And then we have to find the domain and range of the function f and g. So in the first case, a function f from the set A to set B is such that f of alpha 1 is alpha 2, f of beta 1 is beta 2, f of 3 is minus 4, f of k is r, f of w is y. So then the key thing is now to find the value of the function or the domain of the function and the range of the same function. Now remember, domain is the set of all inputs, while the range is the set of all the outputs. So which means to find the domain of the function f, simply identify all the possible inputs, and then to find the range, identify all the possible outputs. So therefore, the domain of f, the set of all the inputs, we have alpha 1, beta 1, 3, k, and w. So this is what defines the domain of that function f. And then the range of that function will be simply given by the set of all the outputs. So range of f, outputs are alpha 2, beta 2, minus 4, r, and y. So this is the answer to first question. Then g, the function from set x to set y, such that g of b is alpha 2, g of a is beta 2, G of 13 is minus 4, G of K is R, and G of W is Y. So set of all the inputs, we have the domain of the function G be A, 13, K, and W, while the range of G, set of all the outputs, we have alpha 2, beta 2, minus 4, R, and Y. So that's the solution for that given question.